In this video, I'd like to talk about the math question of the day for February 2nd, 2023. And for this problem, we need to convert this number 3,791 from decimal or base 10 to ternary, which is base 3. So this is a number that is in its normal form that each of us are used to, the base 10 form, and we need to convert it to base 3. So to answer a question like this, you need to have a deep understanding of number systems and how these different bases actually work. So at this point, go ahead and pause the video, see if you can solve this on your own. And after giving this at least a couple minutes of thought or trying this for a couple minutes, then go ahead and unpause the video and we can go through this together. Now, assuming that you have attempted this problem, we can start going through this together. And as always, if you have any suggestions for future questions of the day, please feel free to leave those in the comments below. And for this, we need to convert this number from decimal, the normal number system, to a base 3 number system. And let's remind ourselves what the base 10 number system is or how it works. We have this number, 3,791, and we're essentially looking at these different place values. Now, for a base 10 number system, this uses 10 different digits, and then we arrange those 10 digits in different places, and that tells us what the number is. But these places are just different powers of 10. So for this place right here, this is our ones place, or this is the 10 to the 0 place. This is our tens place, or the 10 to the first place. This right here is our hundreds place, or the 10 squared place. This is our thousands place, or the 10 to the third power place. So if we kept going, this would be the 10,000ths place, or 10 to the fourth place. If we had a decimal, then this would be the tenths place, or the 10 to the -1 place. The hundredths place would be 10 to the -2. So this entire number system is based on these place values, and all of these place values are different powers of 10. And of course, we use base 10 since we have 10 fingers, but we don't have to use 10. We could really use whatever base we want. If we were, let's say, some alien species that had 8 fingers on each hand, then maybe we would use base 16. So it just depends on what we choose. And computers use a base 2 number system, just zeros and ones to represent any number. Now for base 3, it works the same way, but each of our places would be different powers of 3. So let's look at an example in base 3. And by the way, this would just use 3 digits, and those 3 digits would just be rearranged in different places. So if we had some example, let's say we have 2, 0, 1, 1, 2, then this number in base 3, this would be the 3 to the 0 power place. This is the 3's place, so the 3 to the first place. This would be the 9's place, or 3 squared place. This would be the 3 cubed, or the 27's place. And this right here would be the 3 to the 4th, or 81's place. And if we want, we can convert this to a normal number that we're familiar with, the decimal, or base 10 version of this number, by essentially taking each of these digits and multiplying them by their place value. So if we computed this and turned it into base 10, we have the 2, which is in the 3 to the 4th place, or the 81st place. Then we have a 0 in the 27th place, so we don't need to add that. We have a 1 in the 9's place. We have a 1 in the 3's place, and we have a 2 in the 1's place, or 3 to the 0 place. And if we add all of these together, this is 162 plus 9, that's 171, plus 5 would be 176. So this number in decimal is 176. Now, taking a number from decimal and converting it to another base can be a little bit tricky at first, but it is a fairly straightforward process once you understand it. So let me just make a little bit more room and we can start working through this. But the main idea is that we can imagine this as filling buckets. So let's start by just writing out a bunch of place values for this base 3 system. Let me just fill in many different spots, and we don't need decimals on this one. So this would be the 3 to the 0 place, 3 to the first, and so on. Let me just write these out quickly. And we should also write in their actual values in base 10 so that we can decide which of these buckets you can say to fill first. Now 3 to the 0, that's just 1. Let me use the right pen tool. 3 to the 0 is 1. 3 to the 1 is 3. 3 squared is 9. Then we get 27. 81. We have 243. And then multiplying that by 3, we get 7. 29, multiplying that by 3 would be 2187, and 3 to the 8th would be 6,561. Now, when filling in these buckets, we have 3,791. And this 3 to the 8th place, this is bigger than what we have. So that is not a bucket that we can fill. We can put a 0 there. But we can fill this bucket. We can fill it at least once. If we tried to fill it twice, then that would be too big. That would be roughly 4,300 something. So we can just fill that once. And that gives us 2,187 of this number. Or in other words, we have represented this number here with a 1 in the 3 to the 7th power place, or the 2187 place, and we just need to consider how much we have left. So let's find that difference. If we take 3,791 and subtract this ones digit here in this place value, 2187, then we have 1,604 left over. So now we go to the next bucket, and this one, it looks like we can fill twice. Since if we double 729, we get 1,458, so we can put a 2 in there. But we're going to take our 1,604 and subtract off the 2 in this 3 to the 6th place, or this 1,458. Again, I'm just doubling this number. And when we find that difference, we get 146 that are left. Now, this next place value is the 243 place, or the 3 to the 5th place, but we don't have enough to fill that bucket. So we put a 0 there. However, we do have enough to fill this bucket. So we can put a 1 there. We can't put a 2 because that would be bigger than this. That would be 162, which is too many compared to what we have left. So we have 146, and then we put 1 in this 3 to the 4th place. So let's subtract off an 81 here. So that now we have 65 left. And we go to the next place value, and it looks like we can fill this bucket twice, since 2 times 27 is 54. So let's figure out how many we have left. We subtract here. This is just 11. And it looks like we can fill this bucket one time. If we filled it twice, that would be too many, since that's 18. And we can take 11 minus 9, and we have 2 left. So we don't have enough to fill this 3 to the 1st bucket, so that's a 0. But we do have 2 left over, so we can put those in the 1's place, or the 3 to the 0 place. So in conclusion, this number, 3,791 in the base 10 number system, is equal to 120, 12102 in the base 3 system. And the way to check this is essentially to go in reverse. Take this number that we found in base 3 and multiply it out. For a number in this position, this is the 3 to the 7th position. There is one of them, so that in base 10 is 2,187. We would add that to 2 in the 3 to the 6th position. So we do 2 times by 729, which we know is 1458. We add that to our 2187, and we keep going. There's 0 of these. There's 181. There's 2 27s, 19, and 2 1s. And when we add all of those together, we will get back 3,791.